Hello students, Lesson 3. Lesson 3 is on the cell. The first important key concept is the plasma membrane. I'd like to point out to you that this is an extremely important organelle and that you should definitely watch the two videos that I'm suggesting below my presentation here. Understand that the plasma membrane is made up of, like we did in Chapter 2, phospholipids, cholesterol, glycoproteins, glycolipids. Put this all together and understand the hydrophobic, the hydrophilic interactions with cytoplasm, with interstitial fluid on the outside. You really need to understand this organelle. So again, watch the two videos below, before and after reading that section of your book. Draw the plasma membrane. I'm actually going to give you the plasma membrane as one of your formative assignments, which you have to label. Don't use your book to go back and label it. Have it in your head. Okay, I keep talking about what's in your head. Trust me, Lesson 2, that chemistry that you had to devour, is going to be used from here on in. So take note, for every summative assessment that you get, that's your test, I'm going to ask you at least one, if not two, questions on what is the monomer of the carbohydrate, the monosaccharide. Can you identify a triglyceride, what it looks like? 3 fatty acids and a glycerol backbone. So that was my little infomercial. Please always review that chemistry, okay, because it's going to be used and we can't do physiology without it. Back to key concepts for Lesson 3. Lesson 3, other key concepts. The organelles. You need to not memorize those organelles, just appreciate that the eukaryotic cell, you have eukaryotic cells, not prokaryotic cells. Prokaryotic cells are the bacteria, either ancient or present day. Or eukaryotic cells have all those organelles that have plasma, I shouldn't say plasma, that have membranes encasing them, except for the ribosome. I know I'm saying a lot of information again, but this should be coming out of the reading that you're doing. Eukaryotic cells also do have a true nucleus. The chromosomes are surrounded by phospholipid bilayer. Membranes are key. Okay, the third really important key concept in this chapter is the cell cycle. Understanding that the cell, when it divides, it's not just doing mitosis. That might have been something you learned about in high school, those phases of mitosis. I want to correct this right now. Not every cell in your developed body, you are developed, is dividing. Cells are dividing, in your case, in your body, if something needs to be repaired or something needs to be turned over, like your red blood cell titer. You make thousands of red blood cells a day. There are pluripotent stem cells in your bone marrow that are cued to differentiate by hormones. They carry out the cell cycle. Whereas the cells that are in your brain, the neurons, are not carrying out the cell cycle. So this process of G1S, G2, mitosis, and cytokinesis is very, very important for the normal state of our cells, that they're not in it. We don't want them to be if they're normally just carrying out their homeostatic bliss, I like to say, just making the proteins that define them. Hello, your lens cells are making the protein crystalline. We have our salivary gland cells are making us saliva, which is actually, they're making the protein salivary amylase. Cells that are differentiated are making those proteins and doing what they're supposed to do in our body, and those that are dividing leave this G1 and then enter the cell cycle. This, if it sounds Greek, shouldn't. If you come back to me after you've done your reading and your online work and you come back and listen, this should make sense. And also, the cell cycle can go wrong. There are molecules that regulate the switch from G1, S, G2, mitosis, cytokinesis. They're called cytokinins. Yes, they're little switches that tell the cell to go through the cell cycle. And it's cancer that is an abnormal cell cycle, actually carries cells that carry an abnormal cell cycle. And we know that problems with these cyclins and their regulation and oncogenes can cause the cell to enter into an abnormal cell cycle and actually just keep going through it and through it when it should stop. Important information is my story. So enjoy it, learn it, and I can't wait to read your assignments. Thanks.